Welcome to day 48 of our journey into deep learning. In today's session, we will dive into the basics of neural networks and explore how to use TensorFlow and Keras for building deep learning models. Deep learning is a subset of machine learning that utilizes neural networks with multiple layers. It allows computers to learn from large amounts of data, enabling them to perform complex tasks like image recognition, space recognition, and even self-driving cars. Deep learning powers many of the advanced AI systems we use today. A neural network consists of several key components. The input layer is where data enters the model. The hidden layers are responsible for processing the input, extracting features, and learning from the data. Finally, the output layer produces the prediction or classification. We also use activation functions such as ReLU, sigmoid, or softmax to introduce non-linearity, allowing the network to learn more complex patterns. Forward propagation is a process where input data is passed through the network to make predictions. Each neuron in the network performs a weighted sum of the inputs, adds a bias, and passes the result through an activation function to produce an output. This is how the model makes predictions based on the data it has seen. Backward propagation or backpropagation is a process of adjusting the weights and biases in the network based on the error or loss. It works by calculating the gradient of the loss function with respect to each weight and then using optimization algorithms like gradient descent to update the weights. The goal is to minimize the error and improve the model's accuracy. TensorFlow is a powerful open source library developed by Google that facilitates building and training deep learning models. Keras is a high-level API that sits on top of TensorFlow, providing an easy-to-use interface for constructing complex neural networks. Today, TensorFlow and Keras make deep learning accessible and efficient. To get started with deep learning, we need to install TensorFlow and Keras. Simply open your terminal and type pip install TensorFlow. We recommend using Python 3.x and a Jupyter Notebook environment for an optimal development experience. Once set up, we are ready to build our models. Let's dive into building our first simple neural network. We will use the MNIST dataset, which contains images of handwritten digits. Before training the model, we pre-process the data by normalizing the images and reshaping them to fit the model's input requirements. Our network will have one or more hidden layers and an output layer with 10 nodes, corresponding to the 10-digit classes. Here's a basic example of how to build a neural network using TensorFlow and Keras. First, we import the necessary modules. Then we load the MNIST dataset and normalize the data. Next, we define the model architecture using Keras sequential API, adding layers like flatten, dense, and the output layer with a softmax activation function. Finally, we compile the model, specifying the optimizer, loss function, and evaluation metrics, and train it with the training data. Once our model is defined, we train it using the training dataset with model.fit. This process adjusts the model's parameters to reduce error. After training, we evaluate the model on the test dataset using model.evaluate. The evaluation gives us an understanding of how well the model generalizes to new unseen data with metrics like accuracy and loss. Overfitting occurs when the model performs well on the training data but poorly on new unseen data. To address this, we can use techniques like dropout layers or regularization. Underfitting happens when the model is too simple and does not doesn't capture the underlying patterns in the data. In this case, we can increase the model's complexity or provide more data to help it learn better. Now let's put our knowledge to practice. We will build and evaluate a neural network on the MNIST dataset. As we train the model, we visualize the accuracy and loss curves to monitor the model's progress and performance. Today, we learned the fundamentals of deep learning and neural networks. We explored the structure of a neural network, the processes of forward and backward propagation, and how to use TensorFlow and Keras to build models. We also touched on strategies for handling common performance issues like overfitting and underfitting. Thank you for your attention. I would now like to open the floor for any questions or clarifications you may have.